Topic for today's discussion is bubble sort. Before moving on to bubble sort, let us discuss what sorting is. Arranging numbers in an order, either ascending or descending, is termed as sorting. One such way of arranging the numbers is bubble sort. The basic idea behind this one is you are trying to compare two adjacent values and exchange if they are not in a proper order. My initial data for bubble sort given here is 15, 12, 14, 11 and 13 respectively. The first two adjoining elements are 15 and 12. When I am comparing 15 and 12, 15 is a bigger number, hence I go for a swap. Now the second two adjoining elements are 15 and 14. Since 15 is a bigger number, I am going for a swap. The third adjacent set is 15 and 11. 15 is a bigger number, I am going for a swap there. And the fourth adjacent element is 15 and 13. 15 is a bigger number, again I am going for a swap. Here if you see, the biggest element is getting settled at the bottom. So at the bottom you are able to find the biggest element of all the 5 given numbers. Among the 5 numbers, in order to obtain the last number or the biggest number, I have done 4 comparisons for the given 5 numbers. Taking that data as an input, now I am not going to touch the last element because it is already in the sorted order. I am going to take only the before 4 elements, namely 12, 14, 11 and 13 respectively. The first adjoining pair is 12 and 14. 12 is relatively a smaller number, hence I am not going for a swap. When I am trying to compare 14 and 11, the next adjoining element, 14 is a bigger number, I am going for a swap there. The second adjoining set is 14 and 13 respectively. 14 is a bigger number, I am going for a swap. Hence, after 3 comparisons, if I see, I have obtained the second biggest element. So now I have got 2 numbers in sorted order which are shown in red and as well as underlined. Taking the previous output as an input here, now I am not going to touch the last 2 numbers because they are already in sorted order. I do have only 3 elements which are unsorted. Now I am trying to compare the first adjacent pair 11 and 12. Sorry, it is 12 and 11. So when I am trying to compare 12 and 11, 12 is a bigger number, I am going for a swap there. I am trying to compare the next adjacent pair, namely 12 and 13. 12 is relatively a smaller number, I don't go for a swap there. So after 2 comparisons, I have obtained the third biggest element. So 13, 14, 15. These are in sorted order. Now I have to go for only one more comparison in order to obtain the sorted list. Taking this data as an input, I am trying to compare the adjacent pair which is shown in lavender color, that is 11 and 12. The other 3 numbers are already in sorted order. I don't worry about those numbers. I worry only about this particular pair. 11 and 12. You people can ask, sir, 11, 12 is already in sorted order. In before case also we have seen it has been already in sorted order. The problem is that it is visible for our eyes, whereas with respect to the system, since it is a machine, it doesn't know that the data is already sorted. It goes according to the procedure. 11 and 12 is being compared. Since 11 is relatively a smaller number, all the numbers are now arranged in an ascending order. So let me try to conclude this way. If I am having 5 number, I will be having 4 passes or 4 comparisons. After 4 comparisons, I will be obtaining all the result. This is how the program looks like. Let us move on to the Colab. Let us execute the program. Let us check and verify whether we are getting the output properly. Once we have seen whether we are getting the output, let us try to dissect why they have given 2 for loops, what is the comparison they are doing. Everything we will try to study in detail. When we try to run the function or run the program, we are obtaining the output as I am showing here. So now let us move on to dissect the problem, how they have written it and how we have obtained this particular result. In the bubble sort function, I am passing a list which is a mutable object. It is received as a list there. I am trying to calculate the length of n. The length of the list seems to be 5. Why? Because I have only 5 values there. Now, I do have 2 for loops and these 2 for loops are inner loops. The first for loop tells us that if I am having 5 numbers, I have to sort all the 5 numbers. If I am having n numbers, I have to sort all the n numbers. I am giving the range as n, that is 5. How it is going to work now? It is going to go from 0 to 4. Why? Because 5 is not inclusive there. Why the second loop? The second loop is meant for taking the 2 adjacent elements. That is namely the first element and the second element here. Why n minus I minus 1 is there? When I value is 0, I have to go for 4 comparisons. That is 5 number na 4 comparison. 4 number na you are going to have only 3 comparisons where I will be obtaining 4 numbers. Right? Once I have obtained the last number, that is the last sorted number, I will be having only 4 numbers to get sorted. If I am having 4 numbers now, I will be having 3 comparisons. When you see the j value is trying to decrement there, that is first time it has done 4 comparisons, second time it is comparing 3 elements, third iteration it will be comparing 2 elements, and in the fourth iteration it will be comparing only 1 element. I think I have made my point clear here. Let us try to analyze the when I value is 0 and j value is 0 alone. That is, when I value is 0, when j value is also 0, I am trying to compare the elements which are in 0th position and first position. If I am trying to compare now, 0th position value is a bigger one, I am going for a swap. Then j value becomes 1. I am trying to compare one element present in first index with the element present in the second index. Since the element present in the first index is a higher one, I am going for a swap. Again, I am trying to compare index 2 with the index 3. The values present in index 2 is 15, index 3 is 11, 15 is a bigger number. Again, I am going for a swap. Now, I am coming for the last comparison. That is, when j value is 3, na, j plus 1 is 4. That is, the next adjoining element is 13. 15 and 13 are being compared. As a result, I have obtained the first biggest number. When I am going for the second iteration, namely when I is 1, I will be ignoring or I will be comparing the first 2 elements, namely 0 and 1, which is 12 and 14. I am writing as it is because both the elements, that is 12 is a lesser number, I am not going for a swap there. So I am retaining all the elements there. Then when when j value becomes 1, in First index I'm having 14, the second index I'm having 11. Since 11 is a smaller number, I am going for a swap there. The other elements are present as it is. Then when j value is 2 na, j plus 1 is 3. Again 14 is greater than 13. I am going for a swap there. Thereby on 3 comparisons, I have obtained the second largest number. That is, on pass 2, I have obtained the second largest number. And henceforth, you will be proceeding for I value is 2 and I value is 3 respectively. I hope I have made my point clear. Thank you.